All right, here we go. Systems of equations. This can be a doozy, but because we're flipping the classroom with these videos and you're practicing in class, I think it will be to your benefit. Okay, so let's talk about this first assignment. Solutions to systems of equations. The nice thing is you'll always know if you've got it because you can check your answer just like when you're solving an equation. So let's answer this. Is 0, 1 a solution to the system? First of all, forget this yes or no thing. That is a yes or no question, but the work is much more important. So let's substitute. -3 times 0 minus 8 times 1. So I just substituted my values into that equation and it gives me 0 minus 8 is -8. Aha, checks in the first one. Okay, now let's try the second one. 2 minus x. I'm going to substitute 0 in for x and 1 in for y. 1 equals 2. Not on my watch. That's false. Okay, so that means that no, it is not a solution to that system. But if it did work in both, then it would be a solution. Okay, next one is systems of equations by graphing. So when you are doing this, the first thing you want to look for is it in slope intercept or standard? Right, because if it's in slope intercept, you want to graph the y-intercept and then use the slope. Graph B, use M, get your line, right? In standard, you want to graph the x-intercept and the y-intercept, right? Or you could convert to slope intercept. All right, so what are we going to do in this case? We got -3x plus 3y equals 9. And so I would just, I just find the x-intercept. -3x equals 9 is -3. And the y-intercept is 3. Y equals 9 is 3. So then I'm going to graph x of -3 and y of 3. Draw the line as good as I can. I'm going to use another color for the other equation. So the x-intercept. Oh, because they're both in standard form. Hopefully you know that because we already did some assignments with standard form. So in this one, x would be -7. And then the y-intercept, -7y is -14. So y equals +2. And it's very important to be accurate with this and doing the best I can here. We're going to say they intersect somewhere around there. And so what choices do I have? It's less than -2, but greater than -1. So it's not that. It's not that. It's one of these two. And then the y value where they intersect is greater than 1, but less than 2. So it's got to be this. So this was a harder one because you have to estimate. But hey, I did it. I just So the solution to the system of equations is where the lines intersect. They intersect in one point, and that's how you find it. Just kind of look at it. And, if it was on a test with no multiple choice, then you could just use your decimal approximations. But let's do this one too, because what do you notice about these lines? They're in slope-intercept form. So let me graph this first line, and I'm going to start at my y-intercept of 3, and I'm going to use my slope -7 to go down, and then right 1. This line is like, oh man, I just turned like that. Okay, it's something like that. And then the other one has a y-intercept of -3 and a slope of -1. Oh, that's nice. I know right where the intersection is. Intersection is at 1, -4. And there you go. That's how you do that. So hopefully you really worked hard with the graphing assignments, and now this is just graphing two lines and seeing where they cross. It's really the system part is not making it more difficult. It's that you had to actually learn the first thing, but I hope you did. Now, creating systems in context, I think that there will be several red problems from here, and that's okay. Okay, so we want to start to learn about how to create an equation from given information, and it's going to be all about those units. They tell us what our variables represent. Okay, so it's like this. So the units are the variables, right? We know that from the other word problems, but then we also have the equations. Each equation represents a unit or a quantity, right? So the nice thing is they tell us what the variables represent. H is the number of hats, and S is the number of scarves. Okay, so now we have more units than that. We have kilograms, and items is a unit, right? 15 items. So because the hats and the scarves are the variables, the items and the kilograms are each going to represent one equation. I just want to pause there because that's like once you get that, you'll get this. And until you get that, you'll be like, I think I kind of got it, So the items, 15 total items. Okay, so what are our items? Hats and scarves. So H plus S equals 15. And then kilograms. What do we know about kilograms? Each hat is 0.2. So how about 0.2 H? Each scarf is, he wants to use 2 kilograms of, the scarf is 0.1 S, and then he wants to use 2 total, so that's going to be 2. So I just put all my kilograms into the kilograms equation, and all my the items was the item equation. All right, so give that one a try. All right, interpret points relative to a system. So let's look at this one. Chana and Josiah started skating at the same time in the same direction, but Josiah had a head start of 10 meters past the starting line. Sounds like it's y-intercept. It's Josiah. Yeah, this is Josiah. He's the purple line. because we can see that y-intercept of 10. Chana skated 3 meters per second and Josiah skated 2. And so we can also see that the blue line is rising faster. That's Chana. Okay. So here, so what does point F represent? Okay. So point F is that's Josiah at 25 minutes. He skated, well, I'm just looking at the point here. That's 25, 60, right? So at 25 minutes, he skated 60 meters. Okay. So what does the F stand for? Chana's distance from the starting line. No, it's Josiah's. Totally about Josiah. Josiah's distance from the starting line at a time when he was behind Chana. Yeah, he is behind Chana because she at that same time is way up here, more meters. So that would be B. Okay, so know what the point is and what the units are, and then what that point represents. And again, put your red problems there, and we'll keep working them out one by one. You'll build a better and better understanding. Now, substitution. So we did graphing, and then the second method to solve a system of equations is called substitution. The last one, which we'll do next week, my last week on paternity leave, is called elimination. So solving it, so when we have substitution, we're going to have one equation in standard form and one equation in slope-intercept. Did you notice that? This was in standard and that was in slope-intercept. So that is always how it works with substitution. Now, sometimes they're both in slope-intercept, but for now, at least one. Let's just say at least one. And so the first thing we do, circle the mx plus b of the slope-intercept and substitute it in to the y variable of the standard form equation. So instead of y, I'm going to write x plus 4, because that's what y equals in my second equation. That is the big part. Just stop and see if you can see what I did there. I wrote 12x minus 5y equals negative 20, except I didn't write y. I wrote x plus 4, because in the bottom equation, y equals x plus 4. And now I'm just going to solve it. Distribute. Uh-oh, baby's crying. This is not good. All right, 12 minus 7. 20, 0. So x equals 0. The nice thing about substitution is once you get what x equals, you just use that slope-intercept. Just substitute in what x equals, and you easily have what y equals. This one again, 0, 4. I better go help out with that baby. Bye, guys.